So, progressive web apps. The first thing you might ask yourself when hearing such a term is, what exactly is a progressive web app, or PWA for short? And really, progressive web apps are a thing that have been pioneered by Google over the last couple of years. You can kind of see by the definitions here that really the main goal with a progressive web app is to really start to blur the lines between a web application and a native application that you might have on your phone. There are some benefits for desktop users, but primarily the impact is going to be on mobile. The other thing about progressive web apps is it's not necessarily like a checkbox you can check or a library that you include. It's not binary. And it really becomes a question of how progressive do you want to make the application. In that regard, it's a lot like accessibility, because you're not really ever accessible or not, or a progressive web app or not. Like I said, it's just somewhere in that range of how far you want to take it. The other thing about it is kind of like the Mozilla definition here hints at is that it's not necessarily one thing either. It's a collection of newer technologies that browser vendors have been working towards, and we can use a few of those, namely 3, to start to deliver these native-like experiences. So we kind of said, it's this collection of technologies and it's some sort of range. So what kind of makes a progressive web app a progressive web app? And there's just a few things here that really are kind of at the core of all progressive web apps. And they also have a lot of advantages that go along with them. So the first being that progressive web apps are progressive. And really what this means is that these apps are built with progressive enhancement as a core principle. And so, brief progressive enhancement explanation, like we want to develop a baseline for whatever the least capable browser that we have to support is. And then from there, you want to layer enhancements on top of that baseline so that users with more capable browsers get slightly better experiences. And this is totally okay that someone in IE 11 might see a different experience than someone on the latest Chrome. And in fact, you probably want to do that because, as I've seen in the past, when you try to make IE 7 work like Chrome, the user's going to have a bad day because IE 7 just can't handle that kind of stuff that Chrome can. So you want to make sure that the app is accessible to as many users as possible, and so establishing that baseline where they still get a very good usable experience is key. The next thing that progressive web apps have is that they are responsive. And so I think you'd probably be pretty hard-pressed to find an application that's not responsive today. This has kind of just become sort of the way that we do things now. And so if you're already building your app with responsive web design in mind, like you already have this and you don't really have to do anything more to support it. Next is we want to try and be as independent of the network as we can. That's not to say that your users will never have a network connection. That's probably not realistic. But maybe a little bit more realistic is your user is on a train and the train goes through the tunnel, and while in the tunnel, they lose network connectivity. And then as soon as they come back out the other side of the tunnel, they reconnect again and everything goes on like it should. For that moment that they're in the tunnel, like your app should still continue to work and not give you the old Chrome T-Rex game intermittently. We'll talk about it a little bit more in detail, but we'll use service workers in order to enable this network independence. Progressive web apps should also be discoverable. Part of this is you get for free because you're a web app. So search engines are indexing your apps and they are crawling it, and so you can Google for something that's related to your app, and you will show up in the search results. And that's awesome because that's probably how most users are going to find things anyway. Like if you have to do a search that leads you to an app landing page that has a button that redirects you to the App Store to download the app, you're probably going to be less likely to install that app if it's not something that you really care about. The other thing about discoverability is progressive web apps will use a new web specification called the application manifest specification to declare an app manifest with some metadata about your app so that it can be more discoverable on the device. And we'll get into that a little bit later when we look at a demo. Next, progressive web apps should be installable. And so that kind of piggybacks off of the manifest, but if you meet certain criteria in your progressive web app, some browsers, like Chrome on Android, will prompt you to install the app on your home screen. On iOS, still installable, but Safari doesn't alert you to the fact that it can be installed. You kind of have to know where to go to add it to your home screen, but it can be done nonetheless. Next, progressive web apps should be app-like. And kind of like we said at the beginning, the whole idea is to get your web app to feel closer and closer to a native-like experience. And so one of the things that means, like first and foremost, is your progressive web app needs to be fast. You want to be able to deliver what we call the app shell to the user instantly, so that when they tap on that icon on their home screen, your app UI shows up just like a native app's UI would show up, and then starts loading in content later. Next is progressive web apps are linkable, and because they are just web apps at their heart, each page in your app has a URL, and you can copy and paste that URL and send it to a friend. They open it up in their browser, and they see exactly what you were seeing. Maybe they have to sign in or something like that first, but it's a lot better than the experience like with Apple News, for example. I have a friend that reads his news in Apple News and may find a post on some third-party site, and he goes to share that link with me out of Apple News, and when I get the link, it looks just like a regular link, but when I tap it, I have to download the Apple News app. And on principle, I would not do that now. And so I always will make my friend resend the link to me again, because I'm not going to download an app that I'm not going to use long term to read one article that I can read on the web without the app anyway. Next is re-engageable. So Android devices support a push notification API with progressive web apps. And that's great because you can send push notifications to the user and get them to re-engage with your app just like they would a native app. Admittedly, these features, we're not really seeing them being used widespread because they only are supported on Android. Hopefully, Apple will add support for them in WebKit soon, but just knowing Apple and how that's like a core feature of native apps, I wouldn't be surprised if they drug their feet on that one for quite a while. And then lastly, progressive web apps should be safe. What I mean by safe is that, as we'll see when we kind of look in the demo, a service worker can kind of look like a man in the middle. And so you wouldn't want some rogue ad, for example, to load up on a page and then install the service worker that starts capturing all of your network requests with your sensitive information in them, and then start sending that back somewhere. So in order for your app to be considered a progressive web app, all content has to be loaded over HTTPS. And that's to ensure that the packets that are either outgoing have not been tampered with by anyone, with a rogue service worker. So now that we kind of talked about some of the things that make a progressive web app, and kind of some of what their benefits are, how would you go about making one? And as I said, there's really three main things that we need to do to really take advantage of most of these features. And the good news for us is it's not really that difficult to do these three things. So we'll start with the first, and that is the application manifest. And so we'll take a look at an example here, and you can see it's just a JSON file. I'll point out a few key properties of the JSON file here. The first being short name and name. So this would be an example from Google Maps. The short name property there will be what gets rendered on your device's home screen when it becomes installed. The name is just, of course, what the app is. We have this icons array here, and Google recommends really that you really only need these two size images. If you provide the 192 by 192 and 512 by 512, Chrome can scale those dynamically to almost any situation where your icons will be used. So that again would be on the home screen. Chrome does a nice thing where it will create a splash screen for you when your app first starts up. It will also use the 512 by 512 icon as the icon on the splash screen. Apple does not leverage those icons, so you still have to do your meta tag with like Apple Touch icon or whatever it is to set the icon that will be used on iOS home screens. Start URL is important as well, and so that tells the app when you are in standalone mode that like when the user first fires up the app from their home screen, this is where you should send them. Kind of going along with that is the scope, which in this case is anything under maps. And so that tells the app that if I'm on any URL that's nested under this maps namespace, then it should stay inside of the app shell standalone native-like experience. If I were to link to anything outside of that, then kick me back over to the browser to look at that. And then lastly, these couple colors here are used by Chrome to generate that splash screen. So I forget which one is which. The background color is like the background of the splash screen, and I forget what the theme color does. But those are just kind of some customization options. And you really don't have much other customization options for the splash screen. So like you can't like design this really elaborate thing you want to show. Like Chrome will just do it using your icon, these two color properties. To like add your manifest to your application, it's also very simple. In your index.html file, whatever it is, in your head, you add a link tag, give it a rel of manifest, and then point it at that file. When you do this, and we'll take a look at it when we look at the example here, there is in the Chrome DevTools a tab for application that has a subtab, manifest, that you'll be able to see what Chrome thinks about your app. That's kind of a good way to test whether or not you've linked everything up the right way. So that's really it for manifest. It's really straightforward. We throw together some metadata in a JSON file, reference it in our index.html, and like we're a third of the way there already. The next thing that's maybe slightly more involved is the app shell. And what you're really trying to do, with the app shell is to identify the absolute minimum UI that your app needs to present itself in a native-like fashion. So a couple questions that you can ask yourself to kind of figure out what your app shell should consist of are these here. So what needs to be on the screen immediately? That's typically going to be like your landing view in the app. Other UI elements that are key, so maybe you have like a top bar, some buttons, and then other supporting resources. So like that would be things like the CSS, any JavaScript that's necessary, images if you're having icons, if you're using an icon font, the font itself, things like that are going to be cached using the service worker. So the instant the user fires up your app, those things are returned. And it does not appear like there's any sort of network time to get to your app shell. The reason that you want to make sure that it is the absolute minimum UI is, like I said, this needs to load fast. And so you're never going to be completely independent of the network. So the first time you load the progressive web app up, your app shell should load within like 200 milliseconds. And so our example app is kind of simplistic in that it doesn't do very much. But in a maybe more robust world app, you might also need to leverage tools to split your bundles so that you have your app shell bundle that contains everything that needs to be rendered when the app is loaded, and then maybe another bundle that can be deferred and loaded in with some content or things you know that are for screens later down in the navigation stack that the user has to navigate to first. Once you've kind of identified those and created that bundle of things that can consist of your app shell, you'll move on really to the next thing, and that is the service worker. And so service workers is really where a lot of the magic happens in progressive web apps. And really the sky's the limit as to what you want to do. So like there's no like, hey, this is a service worker. We'll see when we look at some of the example code, but you essentially are just registering event listeners, and when a particular event happens, your service worker will catch it, and you can decide what to do with it from there. So a couple of things that service workers are going to let us enable here is just syncing data with a server in the background, and intercepting network requests and returning cache responses. So this is like really big for the network independence piece that I mentioned, because as your app is making a request, you're going to keep a cached copy of that response so that in the event that the network is down, you just return the response from cache, and it looks like the app is working like it did. The data might be a little stale because maybe they made that request some time ago, and for data that's time sensitive, you probably would want to indicate to the user that they're seeing a cached version of that, and then when they regain network connectivity, you'll refresh it for them. But it also doesn't necessarily require a manual user interaction, because we can do that in the background on the service worker, and just when the network comes back up, make the request again and update the cache. And then lastly, like I mentioned, you can use a service worker to send push notifications to the user as well. Service workers have a life cycle, and so this is just a quick diagram from Google on how that works. And so we'll see it in some example code here in a second, but first you check and see if the browser supports service workers, and if it does, you register it and install it. If it errors out when you try to install it, it errors out, you'll get a console error that it happened. But it doesn't stop anything from the rest of your app from working. You just don't get those things that the service worker was doing for you. Otherwise, it'll activate and it'll stay there until it receives an event that you subscribe to. If the browser becomes constrained on memory, then it will terminate your service worker and free up that memory for something else. And then whenever that app comes back into the foreground, it will restart it back up and pick up where it left off. So here in our index HTML example, to load our service worker, we just had a script tag that references this register worker JavaScript file, which we'll look at right here in a second, to register and install the service worker. So that if check there is, like I mentioned, just making sure the browser supports service workers, and if it does, register it, point it to the file that actually contains the service worker, and then after it's done, we just log out that it had been registered. We'll actually look at the demo app service worker file here in a little bit, and we can see some of the interesting things that that particular app does within service worker. So we kind of talked about these three things that we have to do: add a manifest, decide what our app shell is going to be, and create our service worker. So what does it look like when we pull all of that together? And so that is going to be our demo app here. So if we switch over to my devices, I've got a Android, I believe this is a Nexus 5, and an iPhone SE. This is running a few versions back from Android. The iPhone is running iOS 12, and we'll be using Chrome and Safari, respectively, to demo the app. So we'll just go to the site. I've already deployed the site to GitHub Pages because, again, it needs to run over HTTPS to enable a lot of these features. All right, technical difficulties with the Android emulator. So we might not be able to see some of the prompts to install the app, but we can at least look at it on iOS, and then we'll look at it in Chrome on the desktop as well, so we can kind of see the console outputs and stuff there. As you can see here, like it looks like just like a responsive app, and if you're on Android with a material UI, like it kind of looks like a native Android app. So just a simple app that will show the weather in a few select cities. We can refresh the display, and we can add other cities. So let's maybe just add Boston here, and we can see down the weather in Boston. So that's pretty cool. But like I said, on iOS, you can install it to your home screen. You just kind of have to know what you're doing though. So down here in the share menu, if you scroll way over, there's this add to home screen button that we can hit. And you can see it's using the icon that was specified in the Apple Touch icon in index.html, and we can add it, and then it'll show up right there in our home screen. So then when we go to fire it back up from the home screen, it will notice that it opens up full screen. We don't see any of the Safari UI associated with it. Short of the the notification bar at the top, you wouldn't necessarily know that it wasn't a native iOS app. One of the shortcomings on iOS is that it does not appear that the service worker cache from the Safari browser is shared with the standalone version of the app. So we noticed that we had set Boston as another city here, but we're not seeing Boston in the UI. So hopefully those little inconsistencies with iOS will be improved as time goes on. Apple only recently added support for service workers to begin with to even begin to have some of this stuff on iOS. But yeah, that's really, we can see a great looking experience. We can't really distinguish it from a native app. And if Apple supported more features, we could even make it even closer to a native app. But let's look at the same in Android, in Chrome on desktop here. So the first thing I wanted to point out is all of the log that happened here. So in the service worker code, we just have some console.log lines here. You can kind of see the life cycle in action. So the service worker was registered, and then after it was registered, it was installed. It cached the app shell, which for this app is really just the top bar, the icons, the header, and then like the weather icons, and then the styles for like the card itself. So there's not really a whole lot to its app shell because it's pretty minimal in general. But then the service worker activates, and we can see where it's starting to make some requests out, and the service worker is intercepting those. And so I want to show it here with the network tab open. We're going to do a quick refresh, and actually we'll even, can't see it, it's off screen here, but we'll toggle offline on and refresh. And we can see like it totally just refreshed like we were connected to the network. We can see here in the network tab, some of the requests have the little gear icon next to them. And those are requests that had been made previously that the service worker had cached. And so it's just returning the response that was in its cache. It looks like this one happened to be to Yahoo for the weather. And so maybe that one hadn't been cached yet or whatever the case may be. I thought we would have seen some of these other resources with the gear icon as well. But anyway, so as we can see, like the service worker's working, it's returning those files to us because we did kill the network, and it still renders. We didn't get the TRX screen. Also, kind of interesting in the Chrome DevTools is they've put together quite a few things to help with this. So if you look at the application tab here, you can see sort of like this manifest. I don't know why it doesn't think there's not a manifest. And the service worker and what has been stored by the service worker. So you can come in here and you can clear the site data and all that. If you're in development and you're working on multiple versions of your service cache or your service worker, you might have to come in here and manually update or unregister it, because like if it's the same file name, it'll just like think it's the same one that's already installed. So that's kind of annoying, but hopefully it will get better as service workers become more popular. And then the last thing that's interesting here in the Chrome DevTools is in the audits screen. And so Google has created this product. It used to be a standalone site and then a Chrome extension. Now it's just built right into the DevTools. And it's called Lighthouse. And Lighthouse is a great tool to kind of see how far along you are in the progressive web app range of what you can do. So if you just leave all of the defaults selected and go to run the audits, you'll see it kind of does its thing here, changes the screen size and messes with some stuff, all that. But then it gives you a report. And so you can kind of get a scale here, like across some major categories. And like this one scored pretty well, as I expected it would be, or maybe it would, because it's an example from Google, who has been pushing all this stuff in the first place. So performance nailed it, which is not really that surprising. like less or right above a second in time to interact with the app, which is great. Content paint is pretty quick too. You can kind of dive down into some of that a little bit more. You can kind of see various states of the app as Chrome captured it as it was loading. You can also kind of see how you do on the progressive web app checklist. And so it looks like there are a couple things in here that could be improved on this, maybe just because of how it's hosted on GitHub pages. We're seeing efficient cache policies there. That's all great, and past 20 other lines here, so you can kind of just look at what some of those might be. But in your app, when you run this, it'll give you some good feedback, not only for progressive web apps, but also just in general, things like accessibility, performance, all that kind of stuff. Best practices, I think they're just general web best practices, nothing really specific to progressive web apps here, but it's all kind of interesting just to take a look at how far and how good your progressive web app is. Lastly, Google also provides a progressive web app checklist. So out on the Google Developer Network, we can see the checklist here of all of the different things that Google recommends, how you can test them, and how you can fix them. So this is a nice resource just if you ever get stuck or you run your report and maybe it points something out to you that you should address, but you're maybe not quite so sure how to address it. You can come to this checklist resource and start to get some direction on how to improve those things. And then lastly, on the Google Developer Portal for Progressive Web Apps, if you start this little code lab here, Google will actually walk you through how they built that app that we just looked at. And so you can download the source code. It starts very minimally, and then I think there's 9 steps to this that they'll kind of give you the code for each step, so you can just copy and paste it in, or maybe you want to try and figure it out yourself, but at least you have some example code to fall back on if you do get stuck. And so that'll walk you through identifying what the app shell is, creating the manifest, adding some service workers, and all that kind of stuff. So the last thing I want to show here before we go is just some of the service worker code that our example app uses here. And that's here. So the first thing you'll notice here is just setting up some cache. And then this files to cache array, which is going to contain everything that's needed for our app shell. And then when the app is installed, you can see it's just adding an event listener for the install event. And then on the event object itself, we get some new methods that we can call. We're probably all familiar with event.prevent default or some of those other things that we can do on the web. But this wait until is new, and there's some other cache related things that are new too. But this is really all it's going to do is just cache the app shell. So as soon as the app or the service worker is installed, it's going to cache those files, so that every request after that is just going to get it from cache, and it's going to be blazing fast. We won't have to wait on those resources to load. The other event here that we're listening for is activate, and this is when the service worker is activated. So the browser has installed it, and now it's spun it up and it's ready to go. Maybe it was the first install, or maybe it had been terminated and it's being reactivated again. This will be called again. And And what we're doing here is just doing some caching validation to ensure that, like, maybe if we had a different version of the app now, we get rid of the old version's cache and use them so they may not be backwards compatible, or any other kind of situation you might find yourself in where you need to invalidate the cache. And then last is the fetch event. So this event will get fired anytime the browser makes a request for a resource. So that could be a static resource like your style sheet, or it could be an outgoing request to your REST API. So this one is just doing a quick check to see if you're making a request for data or if you're making a request for a static resource. If you are making a request for data, it's going to first try and see if that has been cached, and if not, go fetch it and then cache the result. If you're making a request for a static resource, though, down here it would hit this and either just return the file right out of cache, or if it's not in cache, fetch the result. And that's really all there is in the service worker. So there's not a whole lot of code here to enable those things. And really, that on install where we cache the app shell and the fetch events are going to be like what gets you the most bang for your buck to go, enable some of those progressive web app features. Yeah, I think that's really all I've got here then. Hopefully you will see that it's pretty straightforward, pretty low risk to enable these things, and you get some pretty good benefits out of doing it. So that being said, are there any questions? Yeah.
So if you go back to the app, turn it offline, you get the functionality of being able to add Boston. What's that experience?
Yeah. So I would expect that to fail because we don't already have that data. So you would over here, right there. So you would probably just need to handle that. However you need to handle it to let the user know, like, hey, we tried to add this. Maybe we saved that you want that location, but its data is not available right now, so we can't display it. If we had cache data, then it would just pop in with the cache data.
Can you build like a skeleton almost, just like something that's temporary with a bundle?
Yeah, and in fact, Google would recommend that you do have the server inject the initial data into index.html so that as soon as it requests that the page, it has its initial data ready to go. It can be rendered immediately. That's what's happening here, actually. It's got some initial data set for New York, I think 56 degrees and cloudy. And when the app first loads, that's what we see, but then it'll immediately make the request for the current weather and then update that to the UI accordingly with that data. Chris?
Is this an answer to like Cordova and PhoneGap? Is this?
Maybe, potentially. Right now, Cordova exposes way more native functionality than progressive web apps can do. So depending on the feature that you are trying to enable, like if you didn't need some of those things that Cordova provides, you maybe could get away with this. But the other advantage there is, like, if your user is specifically looking for a native app in the App Store, like Cordova will let you get that presence. But you kind of have to know, as we saw, at least on iOS, that you can install that app. And so it may not be immediately clear to the user that this app is a progressive web app and maybe has a slightly enhanced experience for them. Anyone else? Yeah.
What use cases are Google recommending, or in your experience, seem to make sense for PWAs, and what use cases, given the current state, don't?
Yeah. So I would say if you're looking for any sort of like tight integration with the device, that's probably the use case for not going down the progressive web app side. But an example that I can give is for a side project that I work on. I have it's a Vue.js app, and it works great on the web and all that. But I had a few users ask me if a native app was in the works. And talking with them, found out that they were on Android, and was like, oh, well, I don't really know the first thing about building Android apps, and like, I could probably take some time to go learn how to do that, but like the turnaround's not going to be anywhere near what you're expecting, you know, to be able to use a native app for. But I can add a service worker and a manifest, and let them install it on their device. Some like older versions of Chrome, I think up to 68 will, or no, starting in 68 they removed it, so up to 67 will pop up a banner, like if you meet the criteria, like install this app. They've since removed that, but definitely makes things a little bit more discoverable for the user. Beyond that, like I would just say if you have a web experience, a web app experience, like it doesn't really take all that much more time to do these things, and so I would just say you may as well just go ahead and do them, and then you know users will be able to get that you know, enhanced feature set as a result. All right, if we don't have any more questions, thanks everyone for coming, and hope you learned a little bit about progressive web apps.